Hi everyone. So today we're going to be going over the second topic for competition 2, which is bit string flicking. And unfortunately, we're a little behind in that the competition is coming up very fast. So we're going to be grinding it out this week because we need to take the competition at the end of this week. And I'm sure a lot of you have FBLA tests like tomorrow. Hopefully they'll be done by then. But we're also planning. So we're recording this and we're gonna record the third topic. But then we're gonna have like a test meeting, and the hope is then you can ask questions there, and anything you may be like uncertain of, to ask us like in person because these are recordings, as you're gonna know when you see this. But yeah. Other than that, we're just going over bit string flicking, and Fawaz and I have looked through it and if you have done comp sci principles, this should be fairly simple. Even without it, it should be, but especially if you've done comp sci principles, this shouldn't be anything very hard. Yeah, anything else, Fawaz? Otherwise, we'll just get into it. Hello, Fawaz? Okay. So just to start off, so these four operators, and right here it's just saying bit strings are frequently manipulated bit by using these operators. And so there's not, and, or, and this last one's called XOR. And you probably can figure out what these three mean, but we're going to go into it in a second. But the important or like new for everyone part here, or I'm sure some of you may know it, but at least we didn't, shift and circulate operators, and that's the main part of this bit string flicking that we need to learn. This is important too. The bits on the left are called the most significant, whereas the right are the least significant bits. And next, it's talking about, this isn't important for the competition, but basically high level languages are the ones that would support using these operations. And flags are like true or false, on or off, basically 1-0 kind of concept, like two options kind of concept. That is a flag. And what it's saying is we use these bit strings to maintain a set, so like multiple of those flags. And then, so this explanation, to summarize, basically what it's saying is if we want to keep 8 different values, which can only be 2 different, on or off, true or false, that kind of thing, we can either have an array, and I think we talked about an array last unit, but hopefully a lot of you already know what that is, where we're storing multiple variables, or we can have one variables that has 8 spots. I'm using the word spots, but really bits, 8 bits, and then you can put each of those true or false, 1 or 0, actually 1 or 0, but you get it, that kind of concept, values in each of those 8 bits. And it's the same thing, we're storing the same data, but here it's saying it's much more efficient and it's saving space, or it specifically says it's clearer if it's only one variable. And then shifting of bits, which is this shift and circulate stuff, is used to multiply or divide by powers of 2. And you would get that if you think of binary, basically. But again, we'll go through it. This is just a statement. Essential for systems programming, program and assembly, language, optimizing code, and hardware design. Again, not important for the competition. But this stuff is actually useful later in real coding. But obviously here we're more worried about theoretical stuff, right? So now we're going to go into the operators. And Fawaz, I think I'll let you take over at shift, which is the harder part. But so I mentioned not, and, or, and XOR. So not. I'm going to start off just showing you with this chart. You can read the description while I'm talking if you want. Not basically means every value, there's going to be a set of values, 2 values that we're comparing. But each of those values can only be a 0 or a 1. As I was just saying, a true or a false. That's how a computer works on the most basic level. It's just a ton of these gates is what we call them. You should have learned all of this in Mr. O'Connor's class if you've been in computer science principles. But gates is how everything on the computer works. And it's just a ton. Like nowadays computers have so many of these individual gates, but that creates everything that a computer does. So here we're just thinking of it at a foundational level. So, but all it can represent is a 0 or a 1, which is binary, as I'm sure you guys know, because we did that last competition. So each can only be a 0 or 1. With that knowledge, now we look at not. Not means that it says here bits that are 0 become 1, and those that are 1 become 0. So what does that mean? You're just taking the opposite. Basically, everything that was already a 0 becomes a 1. Everything that was a 1 becomes a 0. And it's not really a comparison, even though I said it was a comparison. The others are more comparisons. It's just that individual value is opposite. And this can also be represented, and often is in coding, with an exclamation point. That means not slash or parentheses opposite, basically. So next is and this is the comparison kind of thing. Obviously, you can think of it in your head. And only works if both values. So this table is showing the two values in the concept of x and y. It's only true if they're both 1. And true and false is represented with true being a 1 and false being a 0. Okay? So as you can see here, I said, what did I say? It needs 2 1s, right? So 2 zeros gives me false, which is 0. 0 and 1, false. 1 and 0, false. The only condition where an and works is 2 1s, and then you see a true here. So pretty simple. And 2 zeros doesn't work. They both have to be 1. A good way to think of it is true and false. They both have to be true. Or contains and, in that or can be that either can be a 1, or also if they're both 1, that still counts. So this 1 and 1, like I just said, is still true. It counts. Here there's a 1 on the x, a 0 on the y, so there is a 1 in either of the values, right? 1, true. Here there's a 1 on the y, 0 on the x, so there is a 1, true. But when there's 2 zeros, there is no 1 anywhere there, not or, then it's false, okay? And the last one, XOR, sounds weird, but basically it's true if the values are different from one another, and false if they're the same. Okay? So, I mean, it's pretty simple, but so just for example, 0 and 0 are the same values, so it's false. 0 and 1 are different values, so it's true. 1 and 0 are different values, so it's true. 1 and 1 are the same value, so it's false. And that's it for the operators. And that's going to be important for the shift and circulate, sorry, is what it's called. The logical shifts and circulates. They're similar, but they're work differently. So flaws, hello? Yeah, so start at the shift operators and talked about shift. Yeah, sure. Mm-hmm. Oh, I get what you mean. Okay. So what he's saying is like, okay, what he's what he's saying is, I'm sharing the whiteboard with him right now. What he's saying is, I was showing you like 1 and 1, 0 and go to the second slide. 1 and 1, 0 and 0, 0 and 1. I was comparing one digit with one digit, one digit with one digit, right? In reality, I just have it show. Yeah. Okay. So what they were, this is how we learn it in Mr. O'Connor's class too, but what they're showing in the more complicated way, but it's really not, is they're thinking of it in multiple values. So if we have 1 1 0 1 1 and like 1 0 0 0, and they should be the same amount of digits. 5 1 2 3 4 5 1 2 3 4 5. They don't need to be 5, but they need to be the same. If they're not the same, and I think it mentions it here, you add zeros to the left. Yeah, if the operands are not the same length, the shorter one is padded with zeros on the left. So if it's 1 1 0 1 0, 5 digits, and 1 1 1 0, 4 digits, we get an extra 0 on the 4-digit one on the left. Okay? Okay, so now these are both 5 digits, so we don't need to do that. But what I would say is we just use that same, we use one of these same operators, and we just say and then it applies to each individual digit. So for example, we go back here. Let's just say and. So 1 and 1. The same index basically. So we're talking index 0 because remember computer science, the first number is always the index 0. So we're comparing the digit in the same index. 1 and 1, and it's and. So the only way and is true, and true is a 1, false is 0. But the only way an and is a true is if both of these digits are a 1. Even 2 zeros does not count. They both have to be a 1. And if one's a 1, one's a 0, no matter the order, doesn't count. So 1 and 1, that counts. 1 and 0 doesn't count, right? 0 and 0 doesn't count. 1 and 0 doesn't count. 1 and 0. And when I'm saying doesn't count, that's a false. 0 is a false. So every single one of those were false. So that's the solution to the and. Do they call it gate? No, they call it operator. The and operator for these two digits. And then I'm just going to do one more before we go to the shift and circulate. Fools, I'm doing this correctly, right? Just to make sure. Oh, it's to make it easier. Hold up. And then 1, 1, 1, 1. You know what? Okay. But hold up. I'm showing them. Okay. So you see, this is what I was just talking about. This one has 4 digits. This one has 3 digits. So what do? We add a 0 to the left. I mean, pretty simple, right? Just remember that. So he was saying XOR. I like to call it XOR, but it's XOR. Oh, those omega thing, or I forget what it looks like. It's yeah, but where are they? Okay, this is what he's talking about. That's not gonna work. Okay, so no, I'll keep the word XOR, but or XOR. Sorry, don't. It's not XOR. XOR. It looks like that. I hope they'll give you this. Oh, okay. I see what you mean. So anyway, XOR. So what was XOR again? They both cannot be the same. They're true. They are the same. It's false. That's simple. So 1 and 0, obviously not the same, right? False. 1, 1. They're the same. True. 0, 1. Not the same. False. XOR. 1, 1. That is XOR. What? Oh, yes. Wait. What was I right? Okay, wait. Okay, wait. So, guys, okay, so 1 and 0. Wait, the only way XOR is true is if they're not the same, right? So 1 and 0 are not the same, so that is true. 1 and yeah. Okay, so I was doing and I was writing and basically, but 1 and 1 are both the same, so that's false. Remember, XOR, the only way XOR is true is if they're not the same digits. If they are the same digits, it's false. And the same can be 0 and 0 or 1 and 1. And that sounds self-explanatory, but the reason I bring that up is because and only works if it's both 1s, and not if they're both 0s. Anyway, 0 and 1 are both different digits, so that's true, or 1. And 1 and 1 are the same digit, so that's false for XOR. So the solution to these two with the XOR operator is 1, 0, 1, 0. And I think Fawaz is going to finish writing the symbol and then show us the more complicated thing, even though they're not really that more complicated. So basically now, this is what you should have known if you've been through comp sci principles. And then now is where the new stuff starts, but it's very little, really. You should get it pretty soon. Fawaz, you okay? What's going on? Here, write out the XOR symbol. And then... Oh, is that why you didn't do it? Okay, Okay, and so now I'm gonna move back to
The function of
string
the shift
flipping, and here
operator
I'm
is
just
to
on top of
simply
the shift
shift
operators
each
part, but
digit
like they're
by
seeing my
one
screen, but you
to
can
either the
explain it.
left or to the right, whichever direction is specified. Now keep in mind, when each digit is shifted by one, the total number of digits, the length of the
Just
number,
explain it here, and then you can show it to them in a sec. Because they're
has
gonna,
to
I'm sure
remain
they'll
the
be
same.
reading the
Okay,
descriptions as we
so
go.
if we have a 5-digit number and we do like a L shift operation on it by, like, let's say 2, the resulting number should still have 5 digits. So the way it works is when the digit at, let's say we're making a shift to the left, right? The leftmost digit is just simply going to be removed from the number. Okay? So then we have a 4-digit number, and then what we're gonna do is add a 0 on the other end, so it's back to a 5-digit number, right? And we just repeat this process however many times it takes. So basically, the numbers at at the front of the direction, they're just being removed, and zeros are being padded in from the opposite direction to keep the number the same length, right? So 1 XOR C is going to equal capital C, right? So that's our first digit. And then for this next digit comparison, which is D is equal to 0, or D XOR 0, whenever a variable is being XORed to 0, then it's always just going to be the same lowercase letter.
No, it's just it's if it's 0, it is the same. It has to be the same number. Like if it's being compared to a 0, it has to be the same number. If it's 1, it has to be the opposite of that number. And opposite is a
See
not.
that the resulting number is going to be capital C lowercase d, capital C lowercase d, then the number 1, then capital A, then lowercase b, right? So that's what we get from that operation. And then moving on, the final operation that we need to take care of is an L shift of 1 on capital C D 1 capital A B. And when we're taking care of that, we get, remember, it's a shift this time, right? And so the numbers aren't wrapping around. They're simply all going to move 1 to the left because it's an L shift of 1. The capital C gets shifted out, and then a 0 gets padded in from the right to make sure that the number stays 5 digits. And so then we set this equal to 0, 1, 1, 0, 0, right? And what we're going to do now is just determine what each variable is equal to. And so we can see that D is equal to 0. Lowercase d is equal to 0. Capital A is equal to 1, which means that lowercase a is equal to 0, and then b is also equal to 0. And so then knowing that information, knowing that D, A, and B, all in lowercase, equals 0, what we're going to do with that is we're going to go back to the original X number, right? Which was A, B, C, D, E. That was our original number. And we're just going to fill in the numbers that we know, which is A, B, and D. So we get 0, 0, C, 0, E. And so now what this means, this 0, 0, and we can replace C and E with just like asterisks, so they're just unknown numbers. And what this means is that those can be any numbers, and no matter what numbers they are, as long as they're in that position and the zeros are also in those positions, as long as it's always 0, 0, some number, 0, and then another some number, like either 0 or 1, it could be either one of them. No matter which combination of those it is, it's always going to be a true, that number being inputted is always going to result in a true equation. And so we're asked to find the four possibilities, right? And so then the four possibilities are 0, 0, 1, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, and then 0, 0, 1, 0, 0. And then that's our answer right there.
Yeah, I think that's good. Like, as in we don't. Yeah. I think. I mean, they can do the other two examples there on there too. I don't want to make this too long either. So yeah, I mean, yeah. Remember, like I said, the video resources are at the bottom of the wiki. There are more videos here if you want to watch them. The guides, obviously, what we read through is also just a guide in itself. You can read on the wiki, and then there are two more problems we didn't solve. And then I'm sure you're not just gonna remember these if you come back to them later and want to solve them. Problem 1 and 3, which we did. And then obviously the work and the answers are there for you to check, just like we were too. And remember to get to that, you go to acsl.org, then you click, you hover over Get Started Study Materials, then go to Senior and Intermediate. Even if you're in Junior, I would still do this. Contest 2, bit string flicking. Because it's only easier than Senior and Intermediate, so just knowing more is just helpful. But maybe if you're doing practice tests for Junior, I would just go to Junior and then here, short problems, programming problem, and we'll share some practice tests with you. But also, we're definitely going to have a meeting both to have a practice test and to answer any questions and any issues you may be having, and like just figuring out how to solve something you may not know how to, or if you don't understand any of the processes. But yeah, other than that, I mean, we had an amazing performance last competition. We want the same this time. We're a little more behind, but yeah, we just want to come out again. So yeah, that's it. It's online, same format, short test, which is 30 minutes from when you start the timer. Programming, which is I think 48 hours. No, 72 hours, Flaws? 72 hours from when you start the timer. Yeah, that's it. Nothing else. I'll text in the chat if I have anything else to say. Alright, thanks so much for watching, guys.